All right, everybody, we're on our last unit here, Unit 8. So let's see what we got. We've got more calculus. So some differential equations. So this first one here is separable because I can just multiply by dx and then integrate both sides. I've got my x's on one side, my y's on the other. The integral of dy will just be y. The integral of kx dx will just be kx squared over 2 plus c. And then I have my initial conditions. My first initial condition says y of 0 equals 1. So I pop a 0 there, and I pop a 1 right there. And that tells me that 1 is equal to k times 0 plus c. So 1 is equal to c. So now my solution looks like this. Y equals kx squared over 2 plus 1. So now let's do plug in 1 right there, plug in 2 right there, and it becomes 2 equals k times 1 over 2 plus 1. Subtract 1. So 1 is k over 2. So 2 is k. So my final answer is y equals 2x squared over 2 plus 1, which is the same as saying x squared plus 1. And if you check your answer by taking its derivative, you'll see that dy dx is 2x. And that matches up with the k value that we got there. All right, so that's part A. Second one, very similar, except for we want to divide by y to get our letters separated this time because it's k times y. So you divide by y to move to the left side. Integrate both sides, and we get the natural log of the absolute value of y equals kx plus c. Because my initial conditions are positive y values, I can just ignore those absolute value bars. And I can do e to the left side and e to the right side. I'm going to do a little trick here where we have e to the kx plus c. I'm going to rewrite that as e to the k to the x times e to the c. Just using two exponent laws right there. E to the kx can be written as a power to a power. And when you have e to the, and when you have addition up in the exponent, you can write that as multiplication between two different exponents. So what I'm going to do, just to simplify my letters here, is I'm going to rename this thing A, and I'm going to rename this thing B. So my differential equation now becomes A times B to the X. And I'm allowed to do that as long as I do not I'm allowed to rename my arbitrary constants as long as I haven't solved for them yet. Now let's do our initial conditions. So y of 0 equals 1 becomes 1 equals a times b to the 0, which implies that 1 is equal to a. Y of 1 equals 2 implies that 2 equals the 1 I just solved for times b to the 1. In other words, 2 is equal to b. And so we actually just have a simple exponential where we have 1 times 2 to the x. And one thing that's a little confusing here perhaps is how could I check my answer with ky right there? Because if I do dy dx, I get 2 to the x times natural log of 2. Natural log of 2 turns out to be equal to k because my b value was equal to 2. Remember, I defined b as e to the k. And so if 2 is equal to e to the k, then k is equal to the natural log of 2. So it doesn't check out like that. All right, great. Number 16, area between curves. All right, so area between curves, we're going to set them equal to each other. Hopefully these come out as factorable. I think I made it that way. Can't remember. So I subtract to get everything over to one side. Beautiful. Look at how that factors, giving me my two different roots, which are my two different points of intersection. All I need to know now is who's on top and who's on bottom in between those points. So I'm going to choose x equals 0 because that's in between my two boundary points. f of 0 is equal to 2, and g of 0 is equal to negative 2. So I know f is on top. So when I set up my integral, I can do the integral from negative 1 to 4. F of x is on top because it has a positive y-intercept. And g of x is on bottom because it has a negative y-intercept. When I integrate them, I could actually simplify before I integrate because the plus 2 here and the minus negative 2 there makes a 4. So then when I integrate, I have 3x squared over 2, combining my terms to make it a 4x. Add 1 and divide for my power. From negative 1 up to 4 equals whatever. You don't need to sit here and watch me do the plugging in, but you plug in the 4, and then you plug in the minus 1, and you subtract them. All right, next up, we're setting sine of x equal to x squared minus pi x. You're not going to really be able to solve this totally algebraically, but you can write this left-hand side, or sorry, the right-hand side like this. And what this tells me is that if x equals 0 and if x equals pi, then my parabola here, because this is just a parabola, is on the x-axis. So I know that my parabola looks like this. And not coincidentally, because I wrote this problem, we know that sine of x also is 0 at 0 and is 0 at pi. And so we know sine of x goes like something like, ooh, that's a bad sign. Don't judge my sine of x. There you go. So if you're able to visualize the graph, or if you remember your unit circle, you can see that sine is on top in the interval that we care about. So for this region right here, we're going to do sine of x minus x squared minus pi x. And we're going to integrate from 0 up to pi. So the integral of sine is negative cosine, integral of x squared, double negative integral of pi x, evaluated from 0 up to pi. And yeah, same idea, you can plug it in. Cosine of pi is negative 1, so I have positive 1 because of the double negative. 1 minus pi cubed over 3 plus pi cubed over 2 minus cosine of 0 is 1, and the rest of it is 0. So I guess we get something like this silly answer here, where you have 2, and then let's make them out of sixths. So 2 plus pi cubed over 6. There you go. All right, next we're going to rotate a function 360 degrees. So we're going to rotate this thing from 3 to 5. This is our function. So how do I rotate it? Well, if I rotate a function, then I have my curve, and I'm creating a circular disk where the radius of that disk is equal to the function. And so I'm doing that at every point along the interval. I'm creating an infinite number of infinitesimally small cylinders. And the volume of a cylinder is pi r squared times h. So here's pi, here's r, and here's h. That's why they're infinitely skinny. Okay, so let's look at this one here. Oops, okay, so pi from 3 to 5, 1 over 2x minus 4 dx squared. Let's make a u substitution for 2x minus 4. So du is 2 dx, or du divided by 2 is dx. So now our integral is pi, and I can redo my bounds of integration. So if I do x equals 3, 2 times 3, 6. 6 minus 4 is 2. Do the top bound of integration. 2 times 5 is 10. 10 minus 4 is 6. Now I have 1 over u squared times dx, which is du over 2. So pi over 2, integral from 2 to 6 of u to the negative 2 power du. Pi over 2, add 1 to the power and divide from 2 to 6. Pull out my constants of negative pi over 2. U to the negative 1 means a fraction, so a sixth minus a half, and a half is equal to 3/6. So I have negative pi over 2 times negative 2 over 6, which is, I guess, pi over 6. And there you go. That's the volume for part A. Part B, very similar. Pi r squared times the height. Then if I look at sine squared of x, it's not easy to solve that one directly. And so what you can do instead is use your double angle formulas. And I always just suggest you look them up. I, for some reason, can't remember them. But if you look at your double angle formulas, you'll notice one that stands out is cosine of 2 theta is 1 minus 2 sine squared of theta. And if you rearrange that, then you could say cosine of 2 theta minus 1 is negative 2 sine theta. In other words, cosine 2 theta minus 1 over negative 2 is the sine squared that I care about. So my integral now becomes this, not d theta, but dx. And a lot of people would like to switch it, like you can switch it to be 1 minus 2 theta, 1 minus cosine 2 theta over positive 2 if you want to. It doesn't matter. It's the same. I'm going to bring this constant out in front anyway. So I have pi over negative 2, and I'm going to do the integral of cosine. So the integral of cosine is sine. Because it was a 2 theta, I divide by 2. The integral of negative 1, x, not theta. The integral of negative 1 is just x, and that's integrated from 0 to pi. Okay, so sine of pi is 0, and that's great. So we have pi over negative 2 times negative pi. Sine of 0 is 0, so we end up with pi squared over 2. Okay, one more to do. We got a differential equation here. This looks to me like an exact differential equation. Divide everything by x. So you end up with y prime minus 3y equals 5e to the x. Identify that this is written in exact form and that your p of x is negative 3, meaning your integrating factor is e to the integral of p of x, so it's e to the negative 3x. Multiply everything by your integrating factor, so you have e to the negative 3xy prime plus negative 3e to the negative 3xy equals 5e to the negative 2x. Because when you multiply two exponential functions, you add their powers. The left-hand side is a product rule. Notice that this right here is like g times f prime plus g prime times f. Okay, so I can write it as the product rule then of e to the negative 3x times y. Then I can integrate both sides, and integrating cancels out the product rule derivative. Integrating an exponential keeps it the same, but I have to divide by negative 2 to counteract the chain rule. And I put a plus c over there. So then I have, I would actually suggest Yeah, maybe we should use our initial condition right now. So we know that y of 0 equals e. So if I plug that in, then I have e to the negative 3x times e equals 5e to the negative 2 times 0 over negative 2 plus c. In other words, this is e to the negative 3x plus 1, and this is 5 over negative 2 plus c. So if I'm going to try to finish it out up here. That means that c is this weird constant. What did I mess up? Oh, I didn't plug in the 0 for everything. I should have plugged in a 0 right here as well. So 3 times, yeah. Okay. So that just means it's e to the 1. Okay, so let me make this a little bit more clear. So when I plug in 0 here, this becomes 1. This becomes 1. So I just have e and 5 over 2. So my c value is just e plus 5 over 2. And so then I can write my final answer going back to this version of the equation and then dividing by e to the negative 3x, which is the same as multiplying by e to the positive 3x. So e to the positive 3x, I'm going to get rid of this just to give me space. And then I have 5 over negative 2 e to the negative 2x plus c, like that. And that is it. All right, please let me know what I can help with. Happy studying.